What's wrong with the atmosphere? I am Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 8th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you like the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. You'll get automatic notifications when the videos are posted, typically on Sunday evenings. And if you have a question or comment, write it up down below. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Peter Belden, Tim Caston, Evolution Moto, East Lake. These are all longtime viewers and contributors. I do really appreciate your contribution. And then a new contributor, Lewis Jarvis. Thank you so much, Lewis. And then Jake Marlowe, the big contributor for the week. Jake's a longtime viewer as well and is pretty active in the comments section. And I really appreciate the donation, Jake. Thanks a lot. With that, let's get to work. We'll start by taking a quick look at significant wave heights, not just in the Pacific Ocean, but over the entire planet. But we'll start in the Pacific. Little gale is trying, not even gale, low pressure system is trying to produce 24-foot seas here southeast of New Zealand. Really, this is remnants of a previous gale that pushed under New Zealand. We'll get into the details on that in a minute. Another little low pressure system trying to generate some seas, only in about the 10-foot range north of Hawaii, but a little bit is expected from that. Other than that, over in the Indian Ocean, not a whole lot going on. Pretty much the same deal for the Atlantic. But it looks like maybe things will be changing. But before we get into all that, we're going to start by looking at current conditions in our local area. That would be California and Hawaii. We're going to start by looking at the buoys. Northern California, the Point Reyes buoy, number 029. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period. That'd be super long period, very energetic swell, which there is 0.0 feet of swell energy at 33.3 seconds, all the way down to 5 second period. That's just pure wind chop. See, there's a little bump here in about the 9 second range at not even 1 foot, and the same thing, little dribbles out into the 14-15 second period range. So no clear indication of any significant swell. As a result, surf heights, while primary swell 2 feet at 8.6 seconds from 302 degrees, just short period wind swell, 1.7 foot surf theoretically, and then the secondary swell 1.3 feet at 13.1 seconds from 197 degrees. Same deal, 1.7 foot surf. Yeah, there were some thigh high sets down, down in the Santa Cruz area today and up in the San Francisco area. There was maybe some waist high sets, but nothing of any real interest. So then we go down to Southern California. We're looking San Diego. It's a good buoy, sort of capturing the whole Southern California area, anything coming in from the Southern Hemi. The Point Loma South buoy, number 191. Again, the same sort of deal, same profile, little bump of energy at 16 seconds, another at 13 seconds with interspersed wind swell. Just no clear, not even there is one spike at 13.3 seconds at 1 foot. So hence the title, What's Wrong with the Atmosphere? Why is there nothing going on? And we're going to get into that in a minute. Anyway, primary swell 1.7 feet at 12.5 seconds from 180 degrees. That's theoretically 2 foot surf, and we'll be generous and say waist high, something like that. And then some secondary swell, if you want to try to tease that out, 1 foot at 15.7 seconds, but pretty much the same deal. Then we go to the South Shore, Hawaii. We're using the Lanai buoy because it's most protected from wind swell, buoy number 239. It too is showing this just kind of steady background energy, I guess you'd call it. Nothing more than that. Primary swell 2 feet at 10 seconds. So that is so just to be clear, swell is not just one of these little sectors. It's the peak and stuff on either side of the shoulder that comprises a swell. And then we try to tease out if there's separate peaks and try to cut out so there's no overlapping between one swell and another. Sometimes successful, sometimes not so much. Anyway, primary swell 2 feet at 10 seconds from 163 degrees. That's theoretically 2 foot surf, and there were definitely waist high sets on the South Shore this morning. So we're going to poke around the globe and just sort of see what's been happening in the ocean for the past week. We're going to start in the South Pacific here. New Zealand there, Chile right there, and Tahiti's up in this area. We're looking for any seas really bigger than 30 feet. And here we are on Sunday. I mean, there was a gale, but you see it's falling southeast. Any sort of fetch you want has to be pushed up to the northeast to get into like California and Hawaii. That one, yes, it had, what do we see here, 33.6 foot seas, but not aimed up to the northeast. So, that sort of is representative of this constant background, minimal background swell energy that we're getting. There are these sort of gales that pass through. All right, so then finally on Friday, the 6th of September, a little tiny gale developed. I mean, tiny is the operative word here, south of New Zealand with 30.2 foot seas. These are right here, these are the highest seas over this entire domain. At 56 south, 161.2 east, you get the idea. Winds 43 knots in one little grid square there. All this served to do was sort of rough up the ocean in this general vicinity. No real meaningful swell is expected from that. But as we got into Friday, the 6th of August, lo and behold, a legitimate gale developed south of New Zealand with 35.8 foot seas. This would be Friday night into nearly Saturday morning, 38.7 foot seas. Now, mostly aimed off to the east, but there I did go look at the actual winds in that fetch area, and there was a southwest component to it. So some swell is expected to be radiating north. This Saturday, seas are falling from 37 feet down to 36 feet, and by Saturday afternoon, 32 feet, and as of Sunday morning, pretty much nothing. So there is small swell in the water pushing north. We'll get into that when we go look at the surf forecast. Then we do the same thing for the North Pacific, and lo and behold, there was a gale developed on Tuesday with 28 foot seas. I think we got, nope, just 28 foot seas. I thought maybe we got to 29 feet, but you see, mainly aimed, I would say at the U.S. West Coast, but really it was from the California-Oregon border northward, even here in Northern California. No real swell resulted. Yes, you could tick it off and say you rode the first North Pacific swell of the season. It was maybe chest high at a couple of spots. I was really hoping for much more. The outer buoy looked quite good when it hit there, but it just didn't materialize at all in the San Francisco Bay Area, and it's not because it was shadowed or anything. There wasn't much to it. And then after that, we just roll through this, and you can see things pretty quiet until you get to right now, and you see this. We'll get into all those details in a minute. For the South Atlantic, we'll run through this real quick. A definite slowing down of the pattern compared to weeks and months past. We're looking for anything that's like, also notice this. You see in the Hindcast, you see the ice line moving around. They update, this is real ice data from a satellite. They work it into the model. It updates about every 3 days. So you'll see little bits of movement down there. So here we go, 29 foot seas. That's as of now, but it's falling southeast, not aimed at South Africa, and really nothing expected from that. And then the Indian Ocean, a little gale here developed, this was a week ago in I'll call it the central South Indian Ocean, pushing off to the east. Then a little bit more of a pattern started developing here. Notice it was focused over here about a month ago. And if you just get a hint of this here, let's see if this will spin up for us. Oh, no, it's in the forecast. I'm sorry. But in the forecast, you'll see a more active pattern forecast over here, maybe related to the MJO pushing off to the east. And we have not forgotten about the North Atlantic, but just suffice it to say there's nothing going on there. I was out there a week or two ago. And I'm from Florida, and it was pretty flat. I did get to surf a couple of days, but we're talking knee-high, thigh-high, novelty surf for sure. All right, so moving on. We're going to start now looking at the forecast for the North Pacific. We're looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, they help direct their track. We're looking for a trough, a dip into the jet, just like that. That's what's known as a trough. And when the jet does that and creates a trough, that creates a counterclockwise flow aloft. It also manifests itself down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, as they get purchased on the ocean surface, impart energy to the ocean and start generating seas. Those seas eventually radiate away from the fetch area. The lesser period elements get groomed out, and the net result is swell radiating away from there, and swell, when it hits your beach, turns into surf. So we do have a little bit of a trough supporting a little bit of a low pressure system north of Hawaii. We're going to take a look at that in a minute, but that is, it's not a giant good sign, but at least it's something. We're starting to get some movement in the atmosphere. That trough pretty much gets cut off as we get into Tuesday. The jet, you see, sort of ridging well to the north over the Aleutian Islands. You have to have the jet dipping south of the Aleutians. Now, as we get into Tuesday, a little bit of a trough forecast here off of British Columbia, and that's supposed to push south down the coast. Now, not doing anything for California, not really making any fetch, a meaningful fetch to produce surf, but it does sort of suggest perhaps a beginning of change of the season in the Pacific Northwest. Low pressure is scheduled up there to result from that trough. And then as we go further out, the jet looking a little bit better. I mean, generally running, probably about the 48 north latitude line, and cohesive, right? It's not split, it's consolidated the whole way across. And there we go. It even looks better, though still not far south enough, and not energetic enough, but certainly not like way up where it was. So the hope is, give it another week or two, that the jet will start falling south as the change of seasons gets into play. Again, we're speaking to that. The title of the video, what's going on with the atmosphere? There's really two parts to that. One is the Pacific. Like, since July, there really hasn't been anything in the southern hemisphere since mid-July. I think that was the last legitimate swell we've had, so it's been coming up on nearly 2 months now. The same thing is happening over in the Atlantic, not in terms of swell production, which normally is pretty minimal in the Atlantic unless there's a hurricane, but exactly to that, there's been no hurricane activity, and this year was supposed to be an epic hurricane year in the North Atlantic. So we're going to talk about that a little bit more as we get deeper into this presentation. All right, so let's go take a look down at the ocean surface. Surface level pressure, surface level winds. What's going on? Well, we got to have wind to produce surf. So here we go. Here is actually the tiniest and weakest of low pressure systems here. I call it 700 or 800 miles northeast of Hawaii, producing 25 knot winds, aimed reasonably well at the Hawaiian Islands. So we get into Sunday night, which is basically right now, 30 knot winds aimed at the islands, continuing maybe even a little bit deeper into the night, and into early Monday morning, 30 knot winds aimed south. That's good for, 11, 12, not even probably 12-second period wind swell, and aimed well at the islands, sort of basically almost like a cutoff low. But as we get into Monday night, that low's gone. It's all over. Here comes the next low, pushing towards the Pacific Northwest, but no winds of any interest. I mean, we're really looking for 35 knot winds. We don't see it. Lots of 25 knot winds, but really nothing going on. We're out into Saturday, the 14th of August. Still nothing. High pressure in control of the Gulf of Alaska. And here we are, almost 2 weeks out. But you do get this general sense of a flow of tropical activity this way. Some activity trying to, or some of that tropical energy or blow off from the tops of the storms, getting caught by the jet stream here and trying to make it their way across the North Pacific, but just not getting any traction yet. So what effect is all that going to have on the ocean? Well, again, here we are, significant wave heights, North Pacific Ocean, the 18Z run of the model. That was actually from data at 11 a.m. this morning. You see minimal seas. Let's just sort of spin this up. There we go, 13-foot seas. Do we get a little better? There we go, on late tonight. 15.7-foot seas aimed at the Hawaiian Islands, and up to 16.8 Monday morning. Up to 17 feet midday Monday, and reasonably close to the Hawaiian Islands, and then fading from there. That's good for wind swell You can almost see the front of it trying to push down towards the islands and then gone. Beyond that, you see the general flow up, around, over, and down, circulating around high pressure, but nothing getting traction yet. We're already a week out in this model. I don't see anything of any real significance organizing as of yet. Then we go to the South Atlantic, remnants of the gale that pushed under New Zealand that has produced a tiny swell that is radiating northeast. That's all fading out and effectively gone for our purposes. We're looking out beyond anything. Give us even 28-foot seas. Now here's what I'm starting to keep my eye on. It seems far-fetched, especially when the model, like we're out almost a week now. I don't really believe the model going that far, but it suggests some amount of activity pushing under New Zealand with seas 35.8 feet. Can we do any better than that? Nope, 34.8. I mean, well south enough, a good amount of energy, a good amount of momentum. We'll see, one, whether it even makes it this far, and two, will it make it past the tip of New Zealand into the South Pacific, or will it just, basically fade away like everything else has been doing lately? Something to watch for, nonetheless. And then just in part of the spirit of being looking at everything globally, we're going to take a look at the South Atlantic. We'll run this out, looking for any meaningful seas. I mean, if you're closer to Africa, even 25-foot seas would do it. There is a little area of 27-foot seas scheduled on Friday the 13th, but falling southeast, probably some sideband swell, since you're not, versus like in the South Pacific, swell has to travel thousands of miles. Here, what are we talking? 700 miles, 800 miles, something like that, and seas are 25 feet. So yeah, you can actually see a swell front there starting to work its way into South Africa. And then maybe another similar little system 180 hours out. But the pattern definitely is changing. It seems like the focus is fading in the southern oceans, but not yet really established in the northern oceans. Continuing on with that theme, we go to the Indian Ocean. We'll just roll through this. Now there you go. There's 42-foot seas. We'll go back one more, was it? Yep, 42 feet there too. This is on Wednesday, the 11th of September. Now again, sort of that not pushing well up into southern Australia. But again, given the close proximity, you see a swell front starting to impact the coast there. So hope there for sure. And some of this energy hopefully seeping into the Southwest Pacific. Notice the preponderance and steadiness of gale activity here under Australia. And this is not basically a week from now, but maybe starting 5 days. In my mind, that suggests the MJO is moving over this area, and that, I think, would be a good thing. But again, it's a ways out in the model, so we have to keep our eyeball on that. And then, as promised, the North Atlantic Ocean, where are the hurricanes? Water temperatures cooking. One would think that it'd be a hurricane production factory here, but it really hasn't been. So some of the blogs are talking about embedded dust and coming off the Sahara, and that's messing with tropical systems and embedded dry air. So whatever low pressure does migrate off of Africa, off the Sahel region here, just basically withers as it gets off into even a very favorable area for development. The other thing is, one other theory I saw as well, the North Atlantic Oscillations into play, and the storms or the tropical waves are pushing off further north, so in not atmospherically a favorable region as they would if they were coming off further south into what I call the Cape Verde storm corridor, down here around 15 north. Typical flow of storms over the Cape Verde Islands, moving towards the Caribbean, then either following the Bermuda High off to the north, or make it in, if the Bermuda High is strong, into the Caribbean and up. Now, there is a little system over here. It is forecast to develop into some sort of tropical system, but, well, let's see if we can actually get it to play out here on the models. You can see, but nothing too solid. But if you're a surfer in Texas, there is some hope, and maybe even into the Panhandle region. Theoretically, now we're into Wednesday, the 11th September, and that is 32-foot seas. I think that would be highly unrealistic. The GFS model that all this is based on tends to kind of overhype tropical systems, but we'll keep our eyes on that. And then another little tropical system, and yet another behind that on Friday. Let's see what they do. And yet some other sort of a low pressure system pushing off the northeast coast and developing. And lo and behold, we're 150 hours out, and all of a sudden it looks like, hey, we're back in business. North Atlantic looks like what it should look like for this time of year, with swell production here, 1, 2, 3, 4 systems, depending on where you live. Do I believe it yet? No, but at least it's a step in the right direction. So maybe we're not getting skunked completely yet. Wind forecasts, we're mainly looking at potential for local wind swell in California and east shores of the Hawaiian Islands. Here's the low pressure. Hawaii's here, San Francisco there, Southern California down here, Oregon, Washington. You get the idea. We're just going to roll this out. High pressure more or less in control, but we do have this low producing that swell that we discussed earlier for the Hawaiian Islands. Now, trades as we get into Tuesday, or California trades, northwest 15 knots. Not really doing anything for wind swell production, and no meaningful trades for the Hawaiian Islands at all. Wednesday, here comes the weakest of local low pressure systems, 1,004 millibars pushing into the coast, but you do get that interaction with the low and high pressure off the coast, the Gulf of Alaska high, producing a gradient of some degree with 20-knot winds, so minimal junky short period wind swell. The gradient building as we get into Thursday. Trades trying to get established. Still that low pressure hanging north of the Hawaiian Islands. As we're into Friday, here we go. Wind swell for North and Central California. 25-knot winds off of Cape Mendocino. Trades 15 knots for the Hawaiian Islands. Saturday, the gradient starts fading. Maybe even eddy flow, south winds, low pressure there. So you get that counterclockwise flow, and you get that south wind pattern into Central California. Trades for the Hawaiian Islands, 15 knots. We go out to Sunday, more of the same, northwest winds, 15 to 20 knots. So that'll create some upwelling. Temperatures will dip a little bit, not a lot. But ocean temperatures here along Central and North California are actually quite nice, 58, 59 degrees in the the Monterey Bay area, up to 60 or even 61 degrees in some little corners and nooks of the bay there. Trades picking up for the Hawaiian Islands, 15 knots. So what does all this mean in terms of surf? Well, we'll start up in Northern California, Ocean Beach. Here are the surf heights, 1.5 feet. You get the general idea. Here's the winds. And then here we go, this would be Friday. You see some degree, this is wind swell, and there's probably wind swell all in here, but it's such short period junk. The model doesn't interpret it as swell. It's considered garbage, and so you don't get meaningful surf from that. But as we get into Friday, wind swell, and then slowly fading as we get further out into Saturday and Sunday. But you see northwest winds still blowing, probably less than 6-second period. But then we go look at actual swell sizes here, 1.5, 2 feet at 9 to 10 seconds. Okay, that doesn't do much. And then here's your 6 feet at 8 seconds sort of thing. And then you get over here now, 14, 15 seconds, 1 foot or something like that. That is that southern hemi swell that from that gale that pushed under New Zealand. Wasn't really aimed super well to the northeast, and it was a very small system. So it's like dropping a pebble into a pool really hard. You're just not going to get much water displacement and not much of a swell from that. But some background southern hemi swell expected nonetheless for the weekend. Then we go to Southern California, Dana Point, good representation. This is not specific to any one break, just to generalize. Here's the ocean state, a little bit off the coast. Surf heights in the 1.5 foot range. and then building a little bit into the almost 2-foot range, fading to 1.5 feet. Wind's not really an issue. Go look at the actual swell. You know, it's all wind swell and background energy, 1 feet at 11 seconds, 1.4 at 12 right now. But then you get out into Friday, 1.1 feet at 16 seconds. There's actually 17-second period energy that's going to show up even earlier, but it's really tiny. And 1.1 at 16, 15 sort of thing. You get the idea. Small background swell. Now, with that little low developing north of Oahu, there actually will be wind swell. You can see it reflected here, 5-6 foot surf. That's maybe a little bit generous, but still potential for some surf. And that would be on like Tuesday, Wednesday sort of thing, trickling down from there. You see the trades picking up beyond that. Swell sizes, 5.2 feet, 5.6 feet at 9 seconds, building to 5.6 at 11 seconds, and then trickling down from there while we wait for whatever the North Pacific will give us, hopefully something in the next 2 weeks. Then a real quick look over at Jeffreys Bay in Africa. Surf heights, 16, 15 feet sort of thing, trickling down. So we get into Monday and Tuesday. Coming up a little bit, but look at the winds, 32 knots out of the east. That's just not great. And then trickling down from there. Let's go look at actual swell heights. 12 feet at 12 seconds. That's kind of like wind swell, local wind swell. Then another little pulse in here at the 9 feet at 9 seconds. All this just basically wind swell until very last frame here, 7 feet at 16 seconds, 15.8. We'll see if that materializes. And then Bali takes the cake again, as it has for weeks now. Surf steady at like 7.5 feet, going down to 5.5 feet, then back up to 6.5 feet over the next week. Swell sizes, 5 feet at 13 seconds, 5 feet at 14.5 seconds. You can sort of read it, and then another little pulse here, 4.5 feet at 14 seconds sort of thing. So steady surf, nothing huge, fun late season surf. Then finally, the backpackers temperature forecast for the intersection of Tioga Pass Road and the Pacific Crest Trail there in Yosemite Valley. At that intersection, that's about 8,700 feet. That's the black line here. These are temperatures at various elevations from up to 14,000 feet down to 500 feet, right in a column, boom, at that point. You see the red is the freeze line. It's been up at 14,000 feet. Now it's starting to sag down to about 12,500 feet, even dropping as low as 12,000 feet or 11,750 maybe as we get into Sunday a week from now, and even deeper further out. Again, part of that larger pattern of the jet stream trying to push south, you know, not making a whole lot of progress south of the Aleutians, but consistent weak troughing off of British Columbia, pushing down into Oregon and into California, dragging fronts down. Seasonal change in temperature, but at the Tioga Pass Road level, temperatures generally 50 to 55 degrees. One little push here going down to about 45 degrees, then back to the 50-degree range, basically, then down again to the 45-degree range. You know, it's just that steady kind of start nicking into it, things cooling off, seasons. I mean, it's that time of year, but that said, it seems like the seasons are delayed. No big surprise with La Nina trying to get a toe in the door. But is it really successful? We're going to find out in a minute. So let's go take a look long term. What's going on with the two major weather oscillations that affect our weather globally long term? The Madden-Julian Oscillation, MJO, and ENSO, the El Nino Southern Oscillation. We'll start with the MJO discussion. There are two phases to the MJO, the active phase, the inactive phase. The active phase is our friend. It is like a low-pressure system that travels around the planet from west to east on the equator. The active phase on one side of the planet, inactive phase on the other. They rotate around the planet opposite of one another. So you have the active phase wherever you live for a while, typically about 4 to 6 weeks, followed by the inactive phase for 4 to 6 weeks, and then the cycle starts all over again. The active phase of the MJO, being a low pressure system, takes warm, moist air from down, and this is on the equator, from down at the ocean surface, lifts it aloft. That warm, moist air is actually energy that eventually reaches up at jet stream level, gets sucked or ingested into the jet stream, and can energize the jet stream. A stronger stronger jet stream has better potential to create troughs, and troughs, of course, create storms and surf and weather and all that kind of stuff. Inactive phase does the exact opposite. It is like a high pressure system. It cuts the chimney off. You don't get that upward flowing air. The jet stream withers, if not splits. That just builds more high pressure at the ocean surface, does nothing for storm production or weather production, and then you just get high pressure and trade winds. So what we're looking at here is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. There are wind sensors on these buoys. They're not like the NOAA buoys or the SEDAT buoys that are giving you real-time updates every half hour. No, this is just 5-day average wind data. And what we're trying to understand is, are the trades stronger or weaker than normal for this time of the year? Why does that matter? Well, trades stronger than normal for this time of the year would be indicative of stronger high pressure than normal, which is also indicative of the inactive phase of the MJO. If trades are weaker, that means low pressures in the area. Trades are generated by high pressure. So if you have a low pressure, a generalized lower pressure trend, that decreases trades, and you'll see it on this chart. All right, so this is the East Pacific here, West Pacific here. There's the equator. New Guinea there, Ecuador off the chart over here. We're just looking at the arrows. 5-day average winds, pretty strong from the east over the East Pacific. Pretty real strong over the Dateline region or Central Pacific, and moderately strong over the West Pacific. But it is not the actual wind speeds. It is the difference from normal for this time of year, the anomalies. These winds, these trades, a little bit stronger than normal out of the east. So that suggests inactive phase of the MJO. Same thing over the Central Pacific. Now weakening trade winds, and it's just 5 degrees north and south of the equator that all this magic happens. So maybe suggesting that the inactive phase, which looks to be somewhere in this area, is maybe weakening the far West Pacific. That also speaks to, remember when we looked back at the charts and saw the models a week from now saying a lot of activity pushing under South Australia? Again, the global interconnection here. Active phase of the MJO, maybe over the maritime continent, that area, maybe starting to seep into the West Pacific already, dampening trade winds. Maybe that's a theory. We're going to have to dig deeper to go find out. So zonal wind anomalies for the whole planet, both the what has been happening and the forecast down here. The blues, easterly, blues and purples, strong easterly anomalies. That would be the inactive phase of the MJO. Reds, orange, the active phase of the MJO, westerly anomalies. All right, so we can see, oh, and let's get ourselves oriented here. 180, that is the date line, right? The far West Pacific, this is just on the equator, starts about 125 east. So the area where you can almost see a seam in the picture here. The area we're really interested in is from here to about 170 west, 5 degrees north and south of the equator. So we have been in control of a pretty strong inactive phase of the MJO in the Pacific. But as of today, lo and behold, westerly anomalies starting to seep into the far West Pacific, about halfway across the Kelvin wave generation area, and moderately strong. That'll start showing up in that previous chart that we just saw in a day or two. With east anomalies, forecast still pretty strong east of there. As we go, this goes out 2 weeks. They divide it by 5 days instead of 7 days. Not sure why, but anyway, you get the idea. West anomalies pretty much holding here in the West Pacific. East anomalies and the inactive phase of the MJO, I would guess, pushing east of the date line as we get into about September 18th. And my guess is after that, the Pacific will loosen up a little bit. The jet stream North Pacific will start falling south, and maybe we'll be back in business. Next up, cloud cover forecast. Again, if you have the active phase of the MJO, let's say over the Pacific, and it's taking warm, moist air and lifting it aloft, that warm, moist air is going to hit colder air up at jet stream level, condense into clouds. You'll get what they call outgoing negative outgoing long wave radiation anomalies. It's just basically, if you beam a satellite down through clouds, you're not going to get much of a return back to the satellite. So it shows up as negative anomalies, the blues here, which is a sign of the active phase of the MJO. So South America, Central America, New Guinea there, EQ is the equator, dateline right here. Each panel is 5 days going out for 2 weeks. This shows a weak active phase in the West Pacific, getting weaker, and going to dead neutral 2 weeks out. This is the statistic model. The dynamic model paints a much better picture with, if anything, a building active phase of the MJO in the West Pacific. The focus of activity. So this would also speak to that, oh, why is south of Australia getting all the surf a week from now? Well, that's because the active phase of the MJO, wherever it is on the equator, north and south of it is where storms are going to form, depending on what the season is. So it'd make perfect sense that you get building storm pattern under Australia as the active phase starts moving into the Pacific. In the South Pacific, you would maybe, the New Zealand corridor might wake up again, but also given the time of year, this might also mean that, we'll say the dateline region in the North Pacific would wake up as well. It's a bit of a reach, and notice one model says this, another model says absolutely nothing, so 50-50 crapshoot at this point in time. Let's dig a little deeper. Phase diagrams for the same two models, statistic model, dynamic model. Oh, and how do you read this? Well, the MJO moves from west to east, from the Indian Ocean to the Maritime Continent to the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so in the Maritime Continent, no big surprise. But if the dot is inside of the circle or even adjacent to the circle, it is considered very weak. Statistic model says then weak active MJO in the Maritime Continent moving to the West Pacific and exceedingly weak 2 weeks from now. But the dynamic model says the MJO waking up to modest strength in the far West Pacific 2 weeks from now. Hence, those previous charts that we saw, the big disparity between the statistic model and the dynamic model. Again, what's really going to happen? Probably somewhere in between the two. That's what seems to happen. But again, it's 2 weeks out. I don't trust a model that far. Guess we're going to see. Another upper level model. This again shows areas favorable for precipitation, the greens, wet air, the oranges and reds, dry air. So this would be inactive phase, and this would be the active phase. Now, interesting, note this. South America, Africa here, the Caribbean here. If this is Africa and this is the inactive phase of the MJO, hurricanes are heavily influenced by the active phase and inactive phase of the MJO. If the the Atlantic is locked down, the main development region for hurricanes locked down by the inactive phase of the MJO, it would perfectly explain why there is no hurricane activity. And then this model goes, by the 13th of September, the inactive phase moving out, and here's the active phase working its way across the Pacific, but also portions of it also working into, it's the active phase covers nearly half the planet. The inactive phase covers the other 50% of it in some fashion. Active phase starting to move into the West Pacific, 16th of September sort of thing. This would be a big red X for the Atlantic hurricane region to wake up. Maybe. We'll see. Anyway, active phase making its way across the Pacific through about, just about the end of September. This actually, because this is upper level, it's about a week ahead of what happens down at the surface. But anyway, as you get into then October, inactive phase in control, things dying out. So in the Pacific, I'm expecting whatever surf we're going to get for the early fall season to be, let's say, mid to late September, and then we're going to have a down spurt while the Atlantic might get pretty interesting even as we get into the first half of October. Maybe there'll be some makeup for what has not happened thus far. We have one more model, the CFS model. It's a dynamic model, but it is not the GFS. It is not whatever the statistic model is. I think it's the CA model. This showing yet a different version of all that. Okay, again, this is east-west component of the wind, the oranges and reds, westerly anomalies. In fact, this chart actually shows MJO, solid contour. Now, this is past performance, and again, the date line runs right up the middle, so the West Pacific starts at 125 east, so the area we're really interested is right in here. This shows eastern anomalies and the inactive phase of the, you could pretty much connect these two dotted lines. That's the inactive phase of the MJO. Moving out in south of California now, some form of other tropical variability, equatorial Rossby waves setting up, producing westerly anomalies, but I think there's also a component of the active phase. In fact, it's shown here. My guess is it's probably, oh, in fact, you can see it there. There's probably a line in some fashion of it following this path. Pretty weak, though. Westerly anomalies in control for a week and a half, and then easterly anomalies in control, but not filling the west Kelvin wave generation area, just the eastern half of it towards the date line. Still not ideal, but given that it's supposedly a La Nina year, that is to be expected. And then finally, the CFS model going out 3 months, all right? Forecast is up here, past performance is down here, date line's right there. Kelvin wave generation area starts right around here. The yellows are our westerly anomalies, and you just, well, there's the date line right there, and you look out 3 months, westerly anomalies building, filling the Kelvin wave generation area as we get into November, and then filling the entirety of the Pacific as we get into December. I think that's in fantasy land, but it's way better than what the models were showing 2 months ago. And this speaks to some of what the title of this video is about. What's going on with the atmosphere? Why are things not going the way they are? I believe there is a bit of a dynamic going on between both our fading El Nino from last winter and the supposed development of La Nina. So let's dig in here a little bit more. We're going to talk about this. So here's supposedly the westerly anomalies building. This would not be a La Nina if you get westerly anomalies filling the Pacific. They're weak. It's no big deal. There's not a whole lot of warm water off in the West Pacific. We'll get into that in a minute. But here's your easterly anomalies, and they forecast to get not smaller in coverage, but moving more to the east, and that's exactly what we want. Let's overlay the MJO here. All right, so here is the active phase of the MJO. Here's the date line. Here's the active phase moving into the West Pacific. Pretty weak. Now, these two were both connected 2 days ago. My guess is they're still all part of the same thing. It's that same trend, and you see the westerly anomalies being dragged along with that, filling a good portion of the Pacific, filling the Kelvin wave generation area at least by mid-October, and then the whole Pacific as we get into early November. That's probably a bit of a fantasy, but why would that be? Let's overlay the low-pass filter, and here is where the really good news goes on. It speaks to also part of the problem that's going on with the global weather pattern right now. All right, here is the low pressure bias. This is your El Nino signal. You see it was in the Pacific here in May, all but fading, and then when you flop from El Nino to La Nina, the the low pressure bias moves over into the maritime continent, hence all the focus of storm activity on South Africa and into the Indian Ocean and the apparent lack of nothingness in the Pacific. But the high pressure bias, which typically is associated with La Nina, started to build and then just completely faltered in August. Well, actually, completely faltered in mid to late July, right about the time everything went to sleep in the Pacific. Now, let's be honest. The swell machine typically does kind of take a break in July. And the seasons are delayed a little bit too because of this El Nino, La Nina thing. It does strange things with the seasons and pushes them, especially La Nina, pushes them later by about anywhere from 3 to 6 weeks later than normal. But notice this, the high pressure bias, which was supposed to be the big harbinger of La Nina building in the Pacific, died in late July. And nothing's happened. And it's not forecast to come back until the first week of October. And previous runs of the model said, oh yeah, it's going to come back, and when it comes back, it's going to be pretty solid and strong. And now this is like a nothing burger here. I mean, I'm not trying to jinx it, but I'm just saying this has consistently been popping up on the models now. It's exactly what happened with our El Nino last year as we were in the summerish, early fall time frame. The low pressure bias tried to build into the Pacific. It stalled completely. Now our La Nina is doing the same thing. So then you ask, well, why would that happen? And that's where then you get into the debate. Well, is this an effect of global warming or is it a sign of something else? Remember, the PDO is going on too, and it's sort of biased towards La Nina. And one could go, well, it's biased towards La Nina because we're in a global warming pattern, which may be true, or it maybe is just maybe the PDO is starting to shift, or maybe, 10,000 other things are going on. It's too early to know, but what this clearly shows is there's no momentum in the atmosphere. And from just a direct, I want to go surfing, I want to go out in the ocean, I expect there to be some waves. To get storms, you have to have momentum. The pendulum has to be swinging either towards La Nina, towards El Nino. Even if it's swinging towards La Nina, that can help provide energy for storm production. I can't technically describe why, but I know it happens. That said, it really smells as if there's a push from El Nino to La Nina going on right now, but it sure isn't strong. It doesn't have much momentum behind it, and as a result, the storm pattern is lacking because of it. I would say that does have some effect on the hurricane development cycle going on in the Atlantic too. I mean, the Atlantic and the Pacific the rules of physics don't change from one ocean to the next. It's all interconnected. That's sort of this theme we've been going on here of trying to, let's show a broader picture, not just what's going on in the Pacific, but what's going on everywhere. Because what's happening in the Atlantic is definitely happening in the Pacific too, and they're interconnected. I can't explain all of it, but I can say there is a stall going on in the ENSO development, and that would make perfect sense that it's having an effect across the planet. The Atlantic hurricane forecast was screaming, La Nina building, it's going to be great for hurricane development. Everyone, really projected a strong La Nina building, or at least a moderate La Nina, and that isn't happening. In no way, shape, or form can you say it's happening, and there's more evidence of that coming. It is sort of trying to get there, but it's pretty anemic, which I think long-term is good, but we're suffering for it right now from a storm production standpoint. All right, we're going to pick up the pace here a little bit because I rambled there for a bit, but we're going to go now look at another component. This is the El Nino, La Nina component of the discussion. Perfect intro for it, right? Okay, so we're looking at data from the TAO buoy array. Again, the buoys strung across the equator used for monitoring El Nino. These are the anchor lines on those buoys. The X's are sensors. We're looking at subsurface temperature profile, looking for signs of either El Nino or La Nina. We see there was the 30 degree isotherm. It was over like here last week. It's gone. The 29 degree isotherm was at 175. It's moved to 180. The 28 degree isotherm was at 163. It's moved to 168, suggesting trade stronger than normal, moving warm water off to the west, all indicative of some sort of a La Nina pattern building. Certainly taking its time, though. And then we look at anomalies, the difference from normal for this time of year. This really paints the picture, but notice there's a giant gap of missing data here. A bunch of the buoys are down. I think the team is out there working on trying to rebuild out the buoy array as they've done in the West. Hopefully that's what's happening. I don't have a status update on that. Anyway, subsurface temperatures 3 to almost 4 degrees below normal, but this is suspect that it's upwelling here, and maybe it's more over here. In fact, we have another set of data. This image uses the same data, but also has satellite data wrapped in there with it, and you can clearly see warm water in the west, the dividing line right here at 150 west. Cool upwelling to the surface. Ecuador is over here. This is only 5 degrees north and south of the equator. So again, suggestive this is a clear La Nina pattern. Let's dig in a little deeper. Here is the satellite data, sea level anomalies. use a satellite to measure the height of the ocean surface, and based on that, if you strip out the waves, the wind waves, and the tides, is the sphere of the ocean higher or lower than normal? That tells you what's going on down in the ocean surface. If you have negative anomalies, -5, -10 centimeters, oh, and this is Ecuador here, Galapagos here, this is the equator, dateline right there, Central America and Mexico there, New Guinea there. You see right on the equator, right where one would expect a developing La Nina pattern, not a whole lot different from last week, -5 to 10 centimeter anomalies, suggesting cold water at depth here, typical of La Nina and consistent with what we saw in the previous charts. Upper ocean heat anomalies over time. West Pacific here, East Pacific here. Going back a year, September last year, warm water, La Nina, traversing the Pacific, impacting the East Ecuador region, driven by active phases of the MJO. These are Kelvin waves. You've heard me talk about that before. And then the warm pool in the west dried up. Nothing. In fact, we got cool anomalies, and they started making the trip across the Pacific. 1, 2, 3, another one here in July and August, and now it looks like yet another one trying to just get started as we get into September. This all suggests that, well, La Nina, at least in the ocean, is happening, and there's not really, a lot of warm water here in the West Pacific, so even if somehow La Nina collapsed, there's not enough warm water here to go get yourself another El Nino going. Sea surface temperature anomalies. All right, this really tells the story here. South America, Central America, Hawaii, the equator right here. Cold water being driven by that subsurface flow we just looked at, impacting Peru and Ecuador, pushing up to the surface and then getting dragged along the equator out to now past the date line or right to the date line. So this is the broadest footprint of La Nina's cold pool that we've seen yet to date. So this is, I wouldn't call it a major upwelling event, but it is an upwelling event of some point. Notice there's a lot of warm water north and south of it. And yet I saw another article they're talking about, and some of the folks that comment on this video have also said, it is not just the presence of cold water, it is the contrast between the cold water and the warm water that sort of sets this dynamic and affects the weather, which is true. I've seen that from other sources as well. So rest assured your thoughts are correct. Anyway, this is the broadest footprint of the La Nina cool pool so far. The sea surface temperature trend for the past 7 days, well, that bulk of the coldness, I think, really happened last week, even in our last video. And now it seems to be moderating. There's more pockets of warming starting to show up. So we'll see how this plays out. But maybe our cool spurt has, this kind of goes in spurts. They're Kelvin waves. And the MJO pulses and all this stuff interacts, and so it sort of grows and it backs off and grows and backed off. And this seems like a La Nina spurt, or the inactive phase of the MJO spurt, whatever you want to call it. The CDAS Nino 1.2 index is just sort of a rough idea of what temperatures are doing over there by Ecuador. They call it the Nino 1.2 region. Temperatures today, 930 thousandths of a degree below normal, basically 1 degree. Really no change for months. Not getting colder, not getting any warmer. Let's go look at the official El Nino monitoring region. And that is known as the Nino 3.4 region. That is the area on the equator south of California out to almost the date line, 5 degrees north and south of the equator. When you looked at the previous charts, you saw a mixture of cold and warming waters and cold and warm water, but the generalized trend, well, we were up at 0.2 of a degree back at the end of June. We've been steadily going downward. Today's value, 612 thousandths of a degree, not barely half a degree. So you have to be half a degree for 5 consecutive months, more or less, to be in La Nina. We've only dipped our toe in the water for 2 days in the end of July, and now just about the past week and a half, we're finally starting to move into the official La Nina territory temperature-wise. But if that is any sign of what La Nina is doing, and we're here in September, and we're just now starting to barely move out of ENSO neutral towards a fraction of La Nina. It doesn't speak to a very strong La Nina pattern. And here is the Nino, the official Nino 3.4 values this week, the week of August 28th, 0.2 of a degree below normal, which is like nothing. And you can see the trend again. We were in some flavor of El Nino temperatures, well, 0.5 degree, till the 1st of May, and then it just sat there right at dead neutral. And now it's going down, but 0.2 of a degree is like nothing. You got to be at 0.5 degree for 5 months again to be anywhere near La Nina territory. So this suggests that at the ocean, the temperatures aren't even all that cold, and the atmosphere is going to take 3 months to respond to whatever the ocean is doing. So the atmosphere is probably still thinking we're in El Nino, or at best, a neutral territory. Again, that discussion about momentum in the atmosphere. It just doesn't feel like there's any big push. The pendulum is not swinging one way or the other. Certainly not hard from El Nino to La Nina. And so there's no push. There's no momentum. There's no energy to really get anything going. And then there's also the seasonal component. We're in the doldrums of summer right now. The seasons are a bit delayed, okay, because we've been in this multi-year La Nina pattern, and even last year's El Nino was affected by the multi-year propensity for La Nina. It was still present even in the atmosphere and in the ocean last year. And so El Nino did not build as strong as it was expected to build. I think that same sort of just blah in the atmosphere is affecting our development of La Nina, which honestly is probably a good thing. I'll take that over, strong La Nina and just high pressure locking everything down. And then to add to all that, the Southern Oscillation Index, difference in pressure between Tahiti in the Pacific and Darwin roughly in the Indian Ocean. When the index is negative, that suggests at least the active phase of the MJO, but if it's over long periods of time, it suggests El Nino. The daily contribution today, minus 7.25, so certainly not La Nina-ish. We were negative yesterday, but then we did have a run of positive anomalies. In fact, we've probably been more on the balance positive now than negative. Let's go, the 30-day average sort of takes all that into account. The value, 9.41. So clearly indicative, I'm just looking here, well, 50% negative, 50% positive. But that clearly sort of indicates the at least the inactive phase of the MJO. And all the data we just looked at with all the east anomalies and all that suggests, yeah, pretty strong inactive phase of the MJO has been pushing across the Pacific, creating upwelling, blah, blah, blah. You get it. The 90-day average takes all that and just tries to wash it out. The value is 0.71. This speaks to just like some of the other, the official sea surface temperature anomaly record. Just neutral. We had been negative for months, not strong negative, but I mean, this just doesn't indicate any momentum in the atmosphere one way or the other. We're like dipping our toe in the water, but not sure whether we want to go to a La Nina, but we're certainly not going to El Nino, and we're just hanging on the beach doing nothing, getting sunburnt. And here's the 30-day running SOI average graphed out, so you can see what's going on. Here was our La Nina back in 2022. Here was our minimal El Nino. It actually was supposedly, what they call it, a strong El Nino, but atmospherically it wasn't. It didn't get traction. And then here we are just bouncing around neutral since March. Here's our little incursion, putting our toe in the water towards La Nina, but I don't see any massive push in that direction either. All right, so what's the forecast saying? We're looking at the sea surface temperature anomaly forecast for the Nino 4 region, the official El Nino monitoring region. We are in, let's see, there's July, there's right about there's August. It has temperatures like minus 0.2 degrees. And September would be out in here. It shows temperatures down to about 3/4 of a degree below normal. I think that is seeing how this would be September 15th. And today is the 8th. A week from now, is it really going to drop all that far? I'd say probably not. This is overbaked for sure. And temperatures going down to 1.2 degrees below normal. But This model is known, or this version of the model is being known for overbaked, so they build a PDF corrected version of it. It suggests temperatures still down to half a degree below normal by mid-September at least, and we're not there. It ain't happening. Temperatures going down to just barely 1 degree below normal as we get into November. Even that seems a little bit high. We looked at the consensus model, was it last week or the week before, something like that, whenever it's 3 weeks ago. And it showed temperatures somewhere around 0.6 to half a degree below normal, somewhere in there. So this is probably on the extreme side of it. Again, that just the weak energy towards La Nina, this is overhyping it for sure. All right, so what does all this mean? Well, let's start with just locally. There is a tiny little gale that pushed under New Zealand. It's producing some, I'll call it a minimal background southern hemiswell that's radiating north. Should make it up into California by the weekend in Hawaii. Really very little of it reaching into Hawaii since it was mainly aimed east. So mainly California for the weekend, and surf size is in the waist high range, something like that. We're really waiting for the North Pacific to come online, but again, the seasonal delay due to the preponderance of a background La Nina state, or if you want to call it the PDO being in the cold phase, I think that's influencing everything. And then there's just no momentum in the atmosphere. We thought we were swinging hard to La Nina. That isn't happening. At least as of right now. Maybe as we get deeper into fall, the swing will happen more, but it just feels like that isn't going to happen. And as a net result, there is not that much available energy in the atmosphere for storm production, at least not as of yet. As fall comes in the door, and if La Nina doesn't get as much traction as forecast, that might be a good thing. Maybe we'll be in for some storms. Just want to see the North Pacific Jetstream falling a bit further south, and then hopefully we'll be open to actually getting some legitimate fall surf, but I think we're going to be delayed for 2 weeks, maybe 3 weeks. So that said, go do what you need to do, take care of business, and prepare for hopefully something better to come. I wish I had great news, but I don't. You can read the models. You can see it for yourself. Anyway, that's kind of it for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Hit the Stormsurf icon down the lower right-hand corner of the screen. Leave us a comment or question. It helps the algorithm. And if you'd like to make a contribution to the cause, use the super thanks button down below, the heart with the $sign in it. With that, we're done for this week. We will see you again next week. Same time, same channel. Thanks for hanging with us and watching.